Hello everyone, I'm Xiansheng Math. This is part 3 of IB Global, the Math Practice ACT test. Starts on page 32 in the link. Starting at question 11. Before you watch this video, I suggest that you read and try the questions so you know where your understanding is. Alright, starting with 11. Which of the following is equivalent to the quantity 3ab to the third power times the quantity 2b to the second power times the quantity, the opposite of a, to the third power? We need to remember what an exponent does. An exponent counts factors. That 3 means we have 3 factors of 3ab. The 2 means we have 2 factors of 2b. This 3 means we have 3 factors of the opposite of a. So let's first use the definition of exponents. So 3ab times 3ab times 3ab are 3 factors of 3ab times 2b times 2b times the opposite of a times the opposite of a times the opposite of a. All right, did we write that correctly? 3 factors of 3ab, 3 factors, 2 factors of 2b, yeah, 3 factors of the opposite of a. Okay, and remember with multiplication, 4 times 7 is equal to 7 times 4. So if I switch the order of 2 factors, it's not going to change the product. So what I can do is I can switch the b and the 3, and then switch the 3 and the a, and keep on switching factors using the commutative property until I have the factors together as I'd like them. And I'd like to see the numbers together, so I'm going to switch things around until I have 3 times 3 times 3 times 2 times 2. Now I want all the factors, anything that has a factor of a in it together, so times a times a times a times the opposite of a times the opposite of a times the opposite of a, and then times b times b. All right, and remember, the opposite of a is just negative 1 times a is the opposite of a. So what we could do is multiply this out, pretend we don't see that opposite there, and then at the end multiply by negative 1, 1, 2, 3 times. Okay, so if we do this, 3 times 3 times 3 is 27, 2 times 2 is 4, 27 times 4 is 108. And then we multiply our factors of a together. We have 1, 2, 3, 4, 5, 6 factors of a. That's 8 to the 6th. And then b times b would be b squared. We don't need the b to the second. We don't need the multiplication thing. All right. Now we have to multiply by negative 1 3 times. We multiply this by negative 1 once, becomes its opposite. Again, it'll become the original that we had here, and then by negative 1 again, becomes its opposite. So our final product is the opposite of 108, a to the 6th, b to the second, and that is letter A. So 11 is A. All right, number 12 says, sausages are sold in drums of 660, and buns are sold in crates of 1,122. Nathan wants to buy the same number of sausages as buns. Not drums and crates, but sausages and buns. What is the minimum total number of drums and crates that Nathan must buy? All right, when I first looked at this problem, I thought, wow, it's a lot. So I thought, well, I want a simpler version. So I looked at this version. And we want the same number of sausages as buns. And from here, we can see that if we find the multiples of 8 and the multiples of 12, we come upon the least common multiple. And so he's going to need 24 sausages and 24 buns so that he has the same number of sausages as buns. Well, how many drums does he need? 1, 2, 3. And how many crates? 1, 2. Okay, and you're looking at the numbers they gave here. They're trying to make sure that you know your divisibility rules. So we're going to use factoring, prime factorization to help us look at this. So I want the least common multiple of 8 and 12. Well, I look at 8, I see 2 times 4, then 2 times 2. So 8 is 3 factors of 2. And then 12 is 2 times 6, then 2 times 3. So 12 is 2 factors of 2 and 1 factor of 3. All right, so I'm going to need a number that has 3 factors of 2, and that'll take care of these 2 factors of 2, and I'll also need a factor of 3. So I'm going to need 2 times 2 times 2 times 3, and that's 8 times 3, or 24. And in this, I can see the number 8, 2 times 2 times 2. I can also see the number 12, 2 times 2 times 3. So this number has 8 as a factor and 12 as a factor. So it's the least common multiple of 8 and 12 because of the way we did this. All right, so we're going to apply that process here. Just on a problem like this, if you're stuck, think of if you can create a similar problem that you can easily solve and just apply the same problem-solving process. All right, so let's get some space here. All right, so this goes up here now. All right. So let's find, we want the least common multiple of 660 and 1,122. So starting with 660, I see that, well, that looks like 6 times 11 times 10, so I know 11 is a factor. And I know 11 times 6 is 66, so 11 times 60 is going to be 660. And then this is even, so 2 is a factor. 2 times 30, that's is even, so 2 is a factor. 2 times 15. 1 plus 5 is 6, which is divisible by 3, so this is divisible by 3. And you should know that 3 times 5 is 15. So I see 660 has 2 factors of 2, 1 factor of 3, 1 factor of 5, and 1 factor of 11. All right, now for 1,122. Again, I see 11 is a factor because 11 times 100 is 1,100. This is 1,122. So we need 100 11s to make 1,100, and then 11 times 2 makes 22. So we need 100 plus 2, or 102 factors of 11 to make 1,122. So we have 11 times 102. Again, if this is troublesome for you, I suggest reviewing your divisibility rules. All right, this is even, so 2 is a factor. 2 times 51, and 5 plus 1 is 6. 6 is divisible by 3, so 51 is also divisible by 3. And 3 times 17 is 51. So now we can find our least common multiple. It's going to need 2 factors of 2, 3, 5, 11, and 17. So we're going to put the LCM is 2. I could put a 2 squared here, but I'm going to write it out. So it's going to help us to see this number in the LCM and this number too. So 2 times 2 times 3. And if we have 2 2's here, that takes care of this 2 here. So that's why I'm not putting any more 2's. So 1 factor of 3 will take care of both numbers. And then 5, 11, and 17. And if we look at this number, we see that 2 times 2 times 3 times 5 times 11 is 660. And then we see that 2 times 3 times 11 times 17 is this number. Okay, if we multiply this number out, we're going to get 11,220. And two ways to look at from here. Use your calculator. What times 660 equals this? But also we can see that here. Here's 660. What is this? What's missing from, what factor's missing from this number? The 17. So that tells us, and you can test it, 17 times 660 equals this number. So he's going to need 17 drums. And we look again, we see 1,122 with these four factors. What is missing to make this? The 2 times the 5. So that tells us he needs 10 crates. So, and if he has 17 drums, he'll have this many sausages. If he has 10 crates, he'll have this many buns. And he'll have the same number of sausages as buns. So what's he going to need to buy? 17 drums plus 10 crates. And that will be the minimum because we use the least common multiple. And so that's 27 total. And that is H. Okay, this one went on a little long, so I hope this helps you better understand these two problems, and thank you for watching. Please like, comment, share, subscribe, and 再见。